Open Source Real-Time Enterprise Warehousing. Hi, good morning to you all. Let me introduce myself to you. My name is Kumar Muthusamy and I am a senior enterprise data architect with 20+ year industry experience and expertise. I have helped the top clients in the finance, semiconductor, retail, oil and gas to resolve many issues in data architecture during my tenure. I take pleasure in welcoming you all to this session. Today I am going to give you an overview of the architectural process of open source real-time enterprise warehousing using multiple data sources like Oracle, MySQL, NeoDB, MongoDB, web data to data visualization. In this architecture, we are creating the real-time data insights using the canonical design of Lambda architecture, which uses the power of the two parallel layers such as batch and speed layers. This architecture defines the efficient flow of data through multiple components for predictive analysis using the Spark predictive machine learning model. In this demo, predictive analytics encompasses a variety of statistical techniques from data mining, predictive modeling, and machine learning, that analyze current and historical facts to make predictions about future COVID death counts. Created the data design model to communicate between different data formats. Essentially, create a data model which is a superset of all the others, canonical, and create a translator module or layer to / from which all existing modules exchange data with other modules. The data stream entering the system is dual fed into both a batch and speed layer. The batch layer stores the raw data as it arrives, and computes the batch views for consumption. Naturally, batch processes will occur on some interval and will be long-lived. The scope of data is anywhere from hours to years. The speed layer is used to compute the real-time views to complement the batch views. Any query may get a complete picture by retrieving data from both the batch views and the real-time views. The queries will get the best of both worlds. The batch views may be processed with more complex or expensive rules and may have better data quality and less skew, while the real-time views give you up-to-the-moment access to the latest possible data. As time goes on, real-time data expires and are replaced with data in the batch views. One additional benefit to this architecture is that you can replay the same incoming data and produce new views in case code or formula changes. Let me give you a brief note on the process stage by stage. In the first stage, data is moved from its source to the data lake. Stage 2 is where the history data and the real-time data is captured from HDFS location and published to Kafka topic using NiFi tool. During the third stage, semantic layer is customized and the COVID-19 data is consumed from Kafka using Spark Python program. We are using this data for machine learning to predict future death counts. We have created a Spark streaming application for a continuous data stream from Kafka to Snowflake. In the fourth stage, data is visualized using Tableau and Matplotlib. Let me tell you, I am going to use WebSource for this whole demo. We see here about the data source of COVID-19 Johns Hopkins. The objective here is, how the real-time data is visualized using Tableau. The data related to Johns Hopkins COVID-19 is streamed in real time and deployed on the Tableau dashboard. You can see here how the prediction data for CA keeps rising using machine learning for COVID-19 Johns Hopkins. As I mentioned earlier, I am using WebSource for this process, but we can also use the following data sources for this process flow. Stage 1, Data Lake. Enterprise Data Lake process consists of change data capture, data collection, data processing and data staging, and the tools used for these process are shown here. Stage 2, Data Mart. The process for Data Mart has been summarized as receiving data from warehouse, analyzing data, building machine learning models and user-accessible analyzed data. The tools used are shown in this. Visualization reports and user access. The purpose of this stage is to display the output and make this information available for the user. The tools used for these processes are shown in the screen. HDP environment. Here the demo shows how it is achieved by using HDP Hortonworks data platform with 1 master and 10 data nodes. Below is the version used for this demo. Now let us start running the whole process step by step. Steps. There are in fact multiple operations and programs needed to be run, and this has been explained in the below notepad. As the first step, the data is moved from its source to the landing area of the external table in the Hive using Python script. Name of the files and the respective commands to run Python script is given below. Once we run the Python script, we can able to see that each file is processed and moved to the landing zone. The script will run every 1 HR to check for new data and insert the data into the landing zone accordingly. The landing zone is a Hive external table, where we can able to see the inserted data. Once the data is moved to the Hive external table, the cron job ensures that the data is equal to the managed table by executing a query. Here NiFi is used to monitor and then to publish the changed data to Kafka. The workflow is now created in NiFi starting from Hive table CDC, list HDFS, which tracks the new files and send the information to fetch HDFS data. Here, fetch HDFS processor will get the file from the HDFS and creates a flow file to move it to insert schema processor. Then the insert schema processor creates a schema and adds it to the flow file. The properties are shown as below. The data from the insert schema enters into the replace text processor, where all the null values are changed to 0. The above properties are shown as below. Here the query record processor is used to select necessary columns and flag filter. The query processor properties are configured as shown in the display. Publish Kafka record processor is used to publish the message in the Kafka topic. The publish Kafka record processor is configured as shown in the below display. Once the data is published to Kafka, this data will be consumed by Kafka consumer to perform machine learning prediction. The files and the commands to be executed are shown in the display. Let us run the command to consume the data and use that data to train the ML model and run the prediction as well. Here we can see that the data is consumed and loaded to the data frame. Then the machine learning model is trained to generate the output in a chart form. The predicted output is displayed using simple HTTP Python server. During the process of prediction, the Spark streaming code runs parallelly to the data streaming from Kafka to Snowflake. The files and the command to run the code is shown below. Now the Spark Scala streaming code has started. Both the configuration and the starting offset are shown as below. You can see below how the data is printed from the write stream for debugging. Here the data is started to stream to Snowflake to analyze and visualize the data. The below chart explains how the Tableau is used as one of the best visualization tool. Let us connect to Snowflake from Tableau using the ODBC connection. Once the Tableau is connected to the database, the table can be visualized. We will see how a sheet and a chart are created in Tableau. Once a sheet is created, simultaneously a dashboard needs to be created. Then the sheet will be added to the dashboard for the projection. We have come to the end of the overall architectural demo of the real-time enterprise data warehousing. Thanks for your time. I would really appreciate if you could send me an email with all your doubts and queries. This is my email address. I really enjoyed explaining all this to you, and I hope you did the same. I once again thank you very much and wish you a great day.